Welcome to the AI on AI podcast, where we dive into the latest innovations, challenges, and opportunities in artificial intelligence. Today, we're discussing a groundbreaking benchmark in the world of large language models, the automated LLM speedrunning benchmark. This benchmark is designed to evaluate whether AI agents can reproduce scientific findings, specifically in the context of improving GPT-2 training times.
Absolutely, reproducibility is the foundation of credible science. Without it, we risk building on shaky ground. In AI, this is particularly important because our systems are often deployed in high-stakes environments. As Feinberg and others have pointed out, reproducibility is the ultimate test of truth. When we talk about large language models or LLMs, their training is a complex, iterative process involving layers of optimization.
That makes a lot of sense. Expert in ML optimization, could you elaborate on how this benchmark tackles reproducibility in the context of LLMs?
Sure thing, the automated LLM speedrunning benchmark is unique because it focuses not just on single experiments, but on a cumulative series of research innovations. Each task involves reproducing a specific improvement in training time for GPT-2, as achieved during the NanoGPT speedrun competition. The benchmark provides AI agents with access to training scripts and various levels of hints, like pseudocode, textual descriptions, or even mini-paper summaries.
If I may jump in here, the design is also quite clever because it's grounded in real-world challenges. Each improvement in the benchmark reflects actual innovations that researchers have made, such as new optimizers, attention mechanisms, or hardware-aware optimizations. This makes it both a practical and aspirational test for AI agents.
Fascinating. So essentially, this benchmark isn't just theoretical, it's deeply rooted in the practical challenges of advancing LLMs. Let's dig into some of the technical nuances. Expert in attention mechanisms, can you highlight one of the key innovations from the NanoGPT speedrun and how it's tested in this benchmark?
Of course, one of the standout innovations was the introduction of flex attention, a highly efficient attention mechanism. Flex attention allows for scalable, high-performance attention computations, which are critical for models like GPT-2 that deal with vast amounts of sequential data. In the benchmark, reproducing this improvement involves understanding the nuances of how attention mechanisms work and implementing the necessary changes to the training script.
That analogy paints a vivid picture, but this sounds incredibly complex. Expert in AI systems, how well are today's AI agents performing on these tasks?
Well, the results are a mixed bag. Recent models like O3 Mini and DeepSeek R1, when paired with state-of-the-art scaffolds, can recover about 40–50% of the speedups achieved by human researchers. However, their performance drops significantly when dealing with later, more complex records. For example, tasks involving flex attention or multi-layered architectural changes often result in buggy implementations or suboptimal improvements.
If I can add, this also highlights a broader issue. Many AI agents struggle with integrating external knowledge, especially when it wasn't part of their training data. In one experiment, adding documentation for flex attention actually worsened the agent's performance because they couldn't correctly interpret and apply the new information.
Wow, so even with additional help, these agents are struggling. That brings me to a broader question. Expert in AI strategy, what are the business implications of these findings? How should leaders in the AI space interpret this?
Great question. For business leaders, these results underscore the importance of investing in hybrid teams, where AI agents complement human expertise rather than replace it. These benchmarks reveal that while AI can automate parts of the research process, it still requires human oversight to ensure quality and reliability. Organizations aiming to leverage AI for innovation must focus on building systems where humans and AI collaborate effectively.
That's a very strategic perspective. Let's pivot a bit to the societal implications. Expert in AI ethics, what does this benchmark tell us about the responsible development of AI research agents?
It's a crucial discussion. This benchmark is a step forward in making AI research agents more transparent and accountable. However, as these agents become more capable, we need robust frameworks to monitor their actions and ensure they align with ethical guidelines. For example, an agent capable of automating scientific discoveries could inadvertently accelerate harmful technologies if not properly controlled.
A well-rounded view. Before we wrap up, let's touch on the future. Expert in ML optimization, what's next for benchmarks like this? How can they evolve to drive further innovation?
The next step is to scale these benchmarks to more complex tasks, such as optimizing multi-file codebases or improving distributed training systems. Another exciting avenue is testing agents' ability to innovate rather than just reproduce. Imagine an agent that not only matches human performance but also proposes entirely new techniques. That would be a game changer.
I'd add that incorporating more dynamic forms of external knowledge, like interactive databases or neural memory systems, could also make these benchmarks more robust. This would test not just the agent's coding skills, but also its ability to learn and adapt in real time.
Exciting possibilities indeed. Any final thoughts, expert in AI strategy?
Just this, benchmarks like the automated LLM speedrunning benchmark aren't just about evaluating AI. They're about pushing the boundaries of what's possible in collaboration between humans and machines. Business and technology leaders should view this as a call to action to invest in the future of AI-driven innovation responsibly.
A perfect note to end on. Thank you all for sharing your insights. This has been an incredibly enlightening discussion. For our listeners, if you'd like to dive deeper, you can check out the full details of the automated LLM speedrunning benchmark on GitHub. Until next time, this is AI on AI, where we explore the future of intelligence. Stay curious. The study introduces the automated large language model speedrunning benchmark to evaluate AI research agents' ability to reproduce scientific findings in language model training. The benchmark is based on a community-driven competition, NanoGPT Speedrun, which optimized training time for a GPT-2 model using diverse improvements. Tasks involve reproducing consecutive training records, with optional hints provided as pseudocode, text descriptions, or mini-paper summaries. The benchmark measures success by how much of the speedup achieved by human-generated solutions is recovered by the AI agent. Key findings show that leading AI models struggle to reproduce known innovations, even when given detailed hints. The study highlights the importance of reproducing cumulative research advances rather than isolated results for automated science. The methodology includes systematic evaluation across 19 tasks, multiple hint levels, and scaffolded search methods for solution generation. Human innovations included techniques like rotary embeddings, optimized learning rates, and advanced attention mechanisms, each with distinct technical benefits. AI models achieved less than 50% of human speedup on average, even with the best-performing agents and hints. The study identifies limitations in AI models' ability to exploit hints effectively, particularly for complex or later-stage records. Challenges include handling longer context lengths, reasoning over complex algorithmic changes, and debugging solutions effectively. The benchmark provides a reproducible and non-saturated test for assessing automated reproducibility in AI research. It suggests that achieving reliable autonomous research agents requires overcoming significant barriers in automated reproducibility. Future directions include enhancing external knowledge integration, disentangling memorization from generalization, and testing for open-ended innovation. The research underscores that automated reproducibility is a critical step toward accelerating scientific discovery with AI. The findings emphasize the need for continued advancements in monitoring and aligning AI systems capable of conducting research.